Hello everyone. So we're going to be looking at lesson 7 today, which is proving the side angle side, side side side, and the angle angle methods for triangles to be similar. So right in the do now, they're asking if the triangles shown are similar and to explain your answer. So there are two triangles. I will highlight out in the picture the two triangles they are talking about here. We have triangle ADE, okay, and we also have triangle ABC, which is the big triangle. Okay, so it just makes it better to highlight so you can see the two triangles. If I was to draw a picture of the two triangles, we have triangle ADE, and we also have triangle ABC. Okay, so those are the two triangles. If I was to just sketch a little picture here, so you can see where I'm looking at, we have A, B, C, which is the big green triangle, and then we have A, D, E, which is my orange triangle that I highlighted. Okay, and if you're looking at those two, if you notice, they're both sharing angle A up here. Okay, this was actually called the reflexive property when we had started talking about that. We're sharing an angle. Okay, so those two angles must be congruent. Okay, it doesn't matter what, if this was 30, then this has to be 30 as well. They do tell us that the angle D is 36.87, and that angle B is also 36.87. Okay, so therefore, if we know that angle A has to be congruent to angle A, right? It doesn't matter what you solve for, C and E must also be congruent. Okay, so therefore all of the corresponding angles would be congruent in this case. So are they similar? We are going to say yes, because all of the corresponding angles are congruent. All right, and having all the corresponding angles congruent, we're talking about having the same shape in both triangles, so that would be similar. All right, and on the bottom they start talking about the different methods we can use when proving triangles are similar. We have the angle-angle method. That's when two triangles are similar if the two angles of one triangle are congruent to two corresponding angles of the other triangle. So in this case, we had these two angles that are corresponding are congruent, and the angle A, which are being shared in the two, were also congruent. So we can use angle-angle on this triangle, the triangles up top. We have side angle side for similarity. The two triangles are similar if two pairs of corresponding sides are in proportion, and the angle between them are congruent. Okay, we're not going to talk about the sides being congruent. That would be if we were talking about congruent triangles. Okay, the size does not have to be the same, just the shape for similar. Two triangles are similar if all three sets of corresponding sides are in proportion. That would be for a SSS similarity, or side, side, side. Okay, so that's what we have so far. If we flip over our page here, we'll start looking at a simple similarity proof. And just like we did with congruent triangles, with proofs, again, you're going to always start out with your given before I even discuss to you what we're doing here. We're going to write our given out. AD and BC intersect at E. And then they're also telling us that AB is parallel to CD. Okay, so unlike congruency, okay, which is different, when we're looking at similar proofs, okay, here's my symbol for similar. We're looking at angle-angle to prove that two triangles are similar. Okay, so we're looking for angle-angle. I'm going to highlight the symbol up here. So here, we have to know that this symbol means parallel. So if you didn't know that, I would write that down. It means parallel. And when we're looking for parallel, we're looking for our z's, our alternate interior angle. Okay, so you can have our forward z or a backwards z. In this case, they already drew in our arrows for you. But I always like to highlight out my Z. So in this case, we're starting on the parallel line, going across, and we're ending on our parallel line. Okay, so there's my Z, and I am going to label, so inside my orange is my first angle that I want to label, number 1. Inside my orange, I'm going to label that number 2. Those are my alternate interior angles. I also have vertical angles, okay, angles that are across from one another. So I'm going to label this one 3, and I'm going to label this one 4. Notice that I put my 2 arcs because I don't think that all of the angles are congruent, or we don't know that for sure. So those are vertical angles, and I will write that in there. Vertical angles. So when we're writing out our proof, we want to state, just like our congruency proofs, angle 1 is congruent to angle 2, and then we want to state why. In this case, we're talking about parallel lines, so parallel lines form congruent alternate interior angles. Super important that you add that congruent in there. Alternate. Okay. For number 3, I'm going to use my vertical angle. So angle 3 is congruent to angle 4. And I'm going to state my reason, intersecting lines form congruent vertical angles. Again, I want to state that they're congruent. All right, and then since we have 2 sets of corresponding angles, we had angle 1 and angle 2 up top, and we have our angle 3 and angle 4. We are now done with our proof. So we are going to, exactly like we did in our congruencies, we're going to write out what we're trying to prove. We're trying to prove that triangle ABE is similar to triangle DCE. Okay, and that's by the angle method of of similarity. Okay, there are other ways to do this. We could have used 2 sets of parallel angle, alternate interior angles, which I'll show you in the next example. It's just slightly different. I think a lot of students see the vertical angles, so I figured I'd start with that. So for example 2, I am just going to do it slightly different, but our proof is going to end with angle. Okay, so we're still trying to prove that the triangles are similar. So we are going to end with angle. And again, they're telling us that there is some parallel going on, so we definitely want to make sure to look for our alternate interior angles. So here are my parallel lines, and I'm going to look. They don't give me arrows on here, so it might be really, really good to start out with highlighting the 2 triangles that we're trying to prove similar. Okay, so triangle AFB, so it's this one right here. We're trying to prove that similar to DFE, which is up here. Okay, so it's really important to see which triangles we're using so that we can find the correct alternate interior angles. So AB is parallel to ED. So in this case, I'm going to use my vertical angle, my alternate interior angles here by forming my Z. Okay, and there's one set right there. So if we use from orange to orange, I can label this one 1, and I can label this one number 2. Okay, but we can also create a Z going in the opposite direction. So it's just something that we didn't do in the other example. And I just wanted to show you that there's another way to do this question. So if I wanted to look at the other Z here, okay, I could label this one over here number 3, and this one down here number 4. Okay, those are also alternate interior angles. So when I do this proof, it's going to be slightly different than the other one. So number 1 here, I'm going to also write out my statement and reason. Okay, they didn't actually have to tell us that they were parallel because they're telling us it's trapezoid, and using the properties of trapezoid, we should know that opposite sides of the bases are parallel. But again, they told us right in the given, so that's perfect. We're going to state our given. Okay, going right down into our proof here, I'm going to state in the same exact statement, I'm going to do angle 1 is congruent to angle 2. But I'm also going to say angle 3 is congruent to angle 4. And we can say both of those in the same statement because they are both pertaining to the parallel lines. Okay, so parallel lines form congruent alternate interior angles. Okay, this time you don't have to use vertical angles because we're just using both pairs of alternate interior angles. So you're actually done. We have angle 1 and angle 2. That's one corresponding pair of angles. And then we have 3 and 4. So we have our angle that we need in order to prove that the triangles are similar. Okay, and so that one, it makes it a little bit shorter to use both pairs of alternate interior angles, but if you guys see the vertical angles, you could have absolutely used the vertical angles in there and it would have been completely fine. Okay, so moving on to example 3. All right, example 3 is not asking us to complete a proof, so it is slightly different. They are asking us to tell whether the triangles are similar and then justifying our answer. Are they similar? And then if they are, what method did we use? So in order to see if the triangles are similar, we're going to have to look at the angles and the sides. Well, in this case, they only give us 90-degree angle here and here. They don't really give us any other angles. So I'm going to have to set up a proportion to see if the sides are even in proportion. Okay, so if I'm looking here, I want to highlight the corresponding sides. In this case, the 1 would correspond with the 3. Okay, and the 3 would correspond with the 5. Okay, we want to make sure we set up our proportion with the correct corresponding sides. So I know all teachers teach it differently. I'm going to go from big triangle to small triangle. So I'm going to use my proportion setup as big to small. So from the big triangle, I'm going to go 5 over 3. So 5 is the big, 3 is the small, and then I'm going to do equals 3 over 1, orange to orange. So green big, green small, orange big, orange small. Okay, in order to check, I'm going to cross multiply to see if it's going to work out here. 5 times 1 is 5, 3 times 3 is 9. They are not equal, therefore these triangles are not similar. Okay, they are not similar because the sides are not in proportion. Okay, so the sides are not in proportion. Okay, so we're just justifying our work here, justifying our answer with the work that we set up our proportion with. Okay, if similar, state the similarity. These two triangles aren't similar, therefore there is no method that we can use. Okay, and then last but not least, we have another proof on the bottom. So hopefully we're getting the hang of this. Again, I want to start off by looking at the triangles they want, or highlighting the triangles that I'm trying to find similar or prove similar. So DEF is right here, and then BGF is right here. Okay, so we're looking at those two. And it tells us a whole bunch of things. It tells us AD is parallel to CB and DC is parallel to AB. So there are like two different parallel lines going on here. In this case, DC being parallel to AB isn't going to help us with these two triangles. That's why I always highlight them out. So I'm going to use the first parallel here. So we're looking at this right here. And I'm going to put my little arrows so we're looking at these two lines being parallel. So I'm going to create my Z. And there we have it. Okay, so I am going to swoop it out and put numbers in here. So angle 1, we'll make this one. Angle 2, notice that both of those angles are part of my green triangles. And that's one of them. This time I'm going to use the vertical angles again. So I'm just gonna make this one 3 and this one 4. Try to do 2 swoops on both of those. Okay, so I already set up my entire diagram and I didn't even start the proof yet. Okay, similar, again, we're looking at angle, angle. I already have my angles set up. 1 and 2 is my first pair of corresponding angles. 3 and 4 are my second. So first I'm going to write out AD is parallel to CB. I'm gonna copy the given. And I'm gonna write given as my reason. And then for number 2, I'm going to state, I'll do the alternate interior angles first. So we had angle 1 is congruent to angle 2. Okay, and my reason is that parallel lines form congruent alternate interior angles. Okay, number 3, we're going to talk about angle 3 and angle 4. And angle 3 and angle 4 are my vertical angles. So we have intersecting lines. Form congruent vertical angles. We've now talked about both pair of angles, so we can finish the proof by saying triangle DEF is similar to triangle BGF, and they are similar by angle, angle. Okay, so we've used everything in our given, we stated it, we made sure we had 2 corresponding angles. So on the back is your independent practice. Okay, the first question, they want to know, are the 2 triangles similar? They're not giving us any angles here, so they're asking us to set up 3 proportions. Okay, so it might help to circle corresponding sides and then square maybe some of the other ones and then triangle, so you're having 3 different shapes in there to help you with organizing your thoughts. And the same thing with number 2, be really careful. They want us to see if they're similar by setting up just 1 proportion. And then I would just make sure that you're looking at what's going to be corresponding. I'll help you out a little bit with number 2. So the 2.24 has to correspond, since this is the lower of the 2 numbers in the first triangle, it's going to correspond with the lower of the 2 triangles. So therefore they're looking like this. Okay, this is actually a rotation here. Okay, so I just wanted to give you a little bit of a heads up on that. Okay, hope this video helped.